Hi children, welcome to a new session on triangles. In today's class, let's recall the angle sum property of triangles and then pass on to its exterior angle property. In addition, we shall take up congruence of triangles. We are familiar that sum of all the angles of a triangle add up to 180 degrees. In today's class, let's visually check if it's true. There are three methods to do so. The first one is the concept of alternate angle equality. Now look at this video. Here, if we take lines BC and DE as parallel lines and AB as transversal, then angle 1 in both the places is the alternate interior angle. So they are equal. Similarly, if we take AC as a transversal, then angle 2 in both the places are equal. With this, we can prove that angle 1, 2 and 3 added together will be equal to 180 degrees. The next method is flipping the three angles. Now look here. By doing so, we get a straight angle. In other words, sum of the three angles is 180 degrees. The third method is equiangular triangle method. Here, we take three equiangular triangles and place next to each other. Here also we observe that the angle sum property is true. Now let's move on to exterior angle property of a triangle. When one side of a triangle is extended, we get an exterior angle. So an exterior angle is nothing but the angle between one side and the extension of its adjacent side. At every vertex, we can extend in two directions. So we get 6 exterior angles in total. What will be the measure of that exterior angle in terms of interior angles? Look at this video. Now, we can say that the exterior angle is equal to the sum of its interior opposite angle. Next, let's move on to congruency. First of all, what is the meaning of the word congruent? When a pair or set of objects or shapes are equal in size and shape, they are said to be congruent, and the property is called congruency. Now, look at this example. If I place one currency above the other, they coincide, so they can be termed to be congruent. There is another method which is called as the method of superposition. Here I make a trace copy of one figure or shape and place it over the other. If they match, then they are said to be congruent. Now let's feel the beauty of congruency with some real life examples. I hope you all enjoyed that. Let's move on to congruency of geometrical figures. What is the simplest geometric figure we know? Yes, a line segment. I take two line segments and place one above the other. What will happen? They will exactly match each other at both the ends. Hence, the lines are congruent. It can be written as line segment AB congruent to line segment CD. Now look at this case. Here the orientation or direction of the lines are not the same. Are they congruent? We may suddenly jump into the conclusion and say that they are not congruent. But watch this. Now we say it's congruent. Here, we should understand that we are allowed to rotate or translate the shapes, but we are not allowed to bend or stretch the shapes to prove the congruency. Now, let's move on to congruency in angles. The term itself is self-explanatory. When two angles have the same measure, then they are congruent angles. Now, watch this. As I am allowed to rotate, I rotate the angle to prove its congruency. This can be written as angle ABC congruent to angle DEF. Next, let's pass on to congruency in triangles. Two triangles are congruent if all the sides and all the angles of one triangle are equal to the corresponding sides and angles of the other triangle. Now, look at these triangles. Here, line segment AB is equal to QR and BC is equal to PQ. Finally, AC equal to PR. Also, angle A is equal to angle R and angle B is equal to angle Q and angle C is equal to angle P. And the three vertices A, B and C in the first triangle corresponds to vertex R, Q and P of the second triangle. Here you should not change the order. The order is very important. Why? Because the relation of congruence between two triangles should always be written in corresponding or matching parts in proper order. If you name the first triangle as triangle ABC, then the second triangle should be triangle RQP only, and it can be written as triangle ABC congruent to triangle RQP. We have studied in our earlier classes that every triangle has 3 sides and 3 angles. So, do we need all these 6 parts to prove their congruency? No, not necessary. We can prove congruency with the equality of 3 of their corresponding parts. But what are those 3 measures we should consider? But it's very simple. To draw a triangle, what are the values usually given to us? Either 3 sides, side 1, side 2 and side 3, or 2 sides and an angle, side, angle, side, or 1 side and 2 angles. Any one of these 3 criterions is enough to prove their congruency. First, let's start with side, 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 or yes criterion. If 3 sides of one triangle are equal to 3 sides of the second triangle, then the 2 triangles are congruent. Is it true? Let's visually check whether it's true or not. I hope I'm right. Now, let's move on to SAS criterion. So, SAS means 2 sides and the included angle. So, if any 2 sides and the included angle of one triangle is equal to the corresponding sides and the included angle of the second triangle, then they are congruent. Yes, we want the visual proof, isn't it? Yes, now watch this. So, the second one is also true. The third one is ASA criterion. As the name suggests, it is nothing but 2 angles and the included sides. Take 2 angles and 1 side and check with the second triangle. If they are equal, then they are congruent. The last one is a special case. It's about right angle triangles. In a right angle triangle, the side opposite to the right angle is called the hypotenuse. If the hypotenuse and any one side is equal in both the triangles, then they are congruent. This is called as RHS criterion. You might ask a question, what about these criterions? These parts alone are not sufficient to prove congruence, because we can draw congruent as well as non-congruent triangles using the same criteria. For example, look at these figures. In both the triangles, all the angles are equal. But are they congruent? No. So, these criterions alone are not sufficient to prove congruence. I hope you enjoyed this session. Thank you, children.